Flashover is known and feared by many firefighters. Flashover results in a fire inferno inside a room when gases from heated combustible materials suddenly ignite. If flashover occurs, the death toll tends to rise threefold. The room corner test is a large-scale test used to determine the risk of flashover. Here, the test material is an insulated sandwich panel with a core of polyurethane plastic insulation between two metal sheets covered by a thin layer of PVC. During the first few minutes, a lot of smoke comes from the plastic layer. So far, the metal sheets have prevented the flames from igniting the polyurethane insulation underneath. After 12 minutes, though, the metal sheets have expanded. This allows the flames to penetrate the open joints and ignite the combustible polyurethane insulation beneath. The fire soon results in a flashover. The flames force the cameraman to retreat to safety. Such fires have resulted in huge financial losses and even deaths. Sandwich panel fires are very difficult to extinguish and can suddenly trap firefighters. Approximately 90% of the sandwich panels in buildings are insulated with polyurethane or other plastics. How will the fire develop if instead of combustible plastic insulation we use a core of rockwool stone wool? Initially, the thin plastic layer on the metal skins starts smoking as we saw in the first test. Yet this time no flashover occurs. The non-combustible rockwool insulation prevents this danger. And when the gas flame is turned off after 20 minutes, the fire dies out of its own accord. What happens if instead we use a core of expanded polystyrene containing flame-retardant chemicals? This material has, at least in some small-scale tests, been certified as difficult to ignite. The first few minutes look very familiar. Smoke rises from the PVC plastic coating on the metal sheets. After 10 minutes, the heat from the gas burner is the same as a burning armchair, and things start to develop dramatically. As the polystyrene insulation melts, the whole sandwich panel disintegrates and collapses. The flames now have free access to the polystyrene behind the metal skin. The room is transformed into a ball of fire and filled with thick black smoke. In some small-scale tests, fire-retarded polystyrene has been certified as difficult to ignite. In this more realistic large-scale test, however, difficult to extinguish seems more appropriate.